Jai Hind everyone, my name is Kamini. I am a faculty in Ajay Kumar Garg Engineering College in IT department. Today I am going to discuss a topic from the subject programming for problem solving, and the topic is searching. That means we are going to discuss about the searching techniques in C programming. Okay, so what do you mean by searching? Basically, searching means if you want to search anything. Okay, in general terms, searching is if you want to search anything. Okay, like if you want to search a particular song from your playlist, then how you can search? You just type that particular song in your search button and then press search. You get the song. Similarly, if you want to search in computer science, we are having basically lots of data in our computer. Okay, we are having a collection of data, we are having collection of files. Okay, so from that collection of information, if you want to search a particular information, then how you will find that particular information or particular file? Then with the help of these searching algorithm, we are going to search, or we are going to find that particular element or a particular file. Like we are having means we are going to store records in our database. So if you want to find a particular single record in our database, then what we have to do, we are using these searching techniques. Like similar ways, we are having arrays. If you want to find out a particular simple element from the array, then we are applying these searching techniques. In the same way, we are having the text files, means we are having a collection of files in our system. Then if you want to search the particular text file, then how you will find? Then again we are using the searching techniques, because we are having a huge amount of data. We cannot find a simple, but like searching one by one. It is not a good habit to search everything one by one. Okay, instead of that, what we have to do, we have to just we know that we want to search a particular file and the name of the file we know. Then we just put that file into the searching area and just press search. Then we can get the particular file in from that collection of files. Okay, similarly, if you are in trees, we have to find the nodes. In graphs, we are having edges and vertex, and like these all elements we are going to search with the help of these searching techniques. Basically, searching techniques are used in our data structure, where we have to maintain our data structure. Okay, so that time you are having these type of techniques like searching techniques. Okay, we are having two things, like search is successful or search is unsuccessful. When search is successful, when we found the element from the particular files or from the particular data. If we found that particular element, then we can say that the search is successful. And when the search is unsuccessful, when do not find the element. Suppose we are having a collection of elements in a system and we want to find a particular element, but that element is not present and at that file. So our algorithm give the result or give the output that search is unsuccessful. Why unsuccessful? Because we do not find the particular element that we want to find, or we do not get the desired output that we want. Then we can say this is the search is unsuccessful. Okay, like I am having example here. Suppose we want to search a 40. Okay, suppose we want to find 40 in a particular in this particular element. So in this list of element, we are having 25, 10, 20, 15, 17, 27 and 10. We do not found 40 because we do not have the 40 in this area of element. So the search is, we can say, not found. But when the search is successful, we can say the search is unsuccessful when the data we want to find is 40, because 40 is not present in this array of element. But if we want to find this element 15, then we can say search is successful, and with the position at At what position we get the element? Position 3 we get the element, then we can say the search is successful. Okay, now the question arises, why do we need searching? Okay, why we need, as I told you earlier, that we are having a collection of data, we are having lots of data in our computer. So why do we need searching? Searching, as I earlier told, that searching is basically actually we are having a lots of data in our computer system, or in our computer science we are dealing with the data. So there we want to find where we are having lots of data, we are storing lots of data. So to retrieve some particular information, some efficient information from that particular data, then we are using the searching. There we need searching. That means for that means for the you can say for retrieving the information proficiently, we need the searching algorithms. Okay, now searching is basically, we are having two types. We can categorize searching into two types, that we are having two methods to search a particular element. The first is sequential search and the second is interval search. Now what is sequential search? Sequential search means when we want to search the element from the list or an array, then that you can say search is sequential. Now let's take, like, this is the array. Okay, in this we are having some element 10, 20, 15, 30, 35 and 5. These are the elements in the array. Now when we call it the searching is sequential, that means we are traversing each element one by one. Like we want to search element number 5. Okay, this is the element we want to search. Now for searching this element X, what we have to do? We have to start searching from here. That means we have to sequentially traversing. That means each position we have to traverse. Like first we are going to search at this position, then we have to move at second position. Here we have to check the particular element that we want to find. Now again we are moving from next position, then we are moving from the next, again we are checking that the element we want this or not, then again if not, we are moving from another location to another location. Now at the end, at the last location, we found the element that we want. That means element found at this position, found. So similarly, what is sequential searching? Sequential searching is basically traverse sequentially. That means we are traversing one by one in a sequential manner. We cannot skip. What is sequential manner? We cannot skip any position. That suppose we are starting from here, then we cannot skip. We cannot skip from first to third. We have to traverse each and every element every time. That's why we call it sequential. And the example of sequential search is linear search, that we are going to discuss in this video. Now second type of search is interval search. What is interval search? Basically it is just opposite to the sequential search. Here what we have to do, here we are using the like this search is basically target the center of the search structure. Okay, like okay, like we are having again we are having some elements in our okay, we are having a array and in this array we are having some elements. So what we have to do with the help of this interval search, what we have to do in this type of searching, the list of elements are divided into two parts. This is first part, this is second part. Okay, you can say this is divide the search space into half. We are going to divide this proper searching space into two parts. Then what we have to do, we have to just search from this first part and we are searching from this part differently. Okay, so this type of searching is known as interval search, where what we have to do, what we are just doing, basically divide the search. With the help of dividing this searching space, we are going to search a particular element. Okay, now basically there is one constraint in this type of searching. What is that? That in this type of searching, the element should be in the sorted manner. Like here, as you see, these are designed for searching in sorted data structure. Now what does it mean, sorted data structure? Basically, sorted means our data should be arranged either in the ascending order or in the descending order. Like this, I am taking this array of elements. Here my data are sorted in a ascending manner. Okay, now you can say this is the sorted array. So what is the constraint here? That the interval search, if you are going to apply and in any type of searching space, then what does required is the list of element should be in a sorted manner. I hope it is clear to you all. Now, and the example of this type of search is binary search. Now, searching algorithm. Okay, as I have told you that we have two type of searching algorithms. First is linear search, that is of type sequential search, and the second one is the binary search, that is of the type of interval search, as I just interval search. Okay, now we will discuss one by one what is linear search and what is binary search. Now, linear search, basically you can say this is the simplest searching algorithm, and you can say this is a traverse the array sequentially to locate the required element. That means we are just, what we are doing, we are sequentially basically sequentially we are traversing. Okay, now what will happen, or what is happening in this linear search, we are going to basically compare every element one by one. Okay, we are going to compare every element one by one with suppose we want to search the element x. Now what will happening here, we are just going to compare this x with the other element that we want to, like in this array I am having 3, 4, 5, 1, 4 and 10. Now what does it mean? We are searching the element by comparing it with each element of the array one by one. It means is, suppose we want to search this x, then what we have to do, we have to compare this x with the first element. Like suppose this is the 0, 1, 2, 2, 3, 4 and 5. These are the indexing of the element. Now if you want to search x, now what we have to do, we have to compare each element. Like suppose x, we are having x equals to okay, so we have to compare x equals to a of 0. Suppose this is the array of a. Okay, now if you want to find out the element x, then what we have to do, we have to compare this element with each element in this array. Now we have to compare 10 equals to what is at the position of a of 0, 2. Is this equals to? No. Again we have to compare x equals to 3. Is this equals to 3? No. So what we are doing, we are just comparing it with each element of the element one by one. Okay, now we will discuss in more elaborated way in next slide. Okay, so it is also known as, I have told you, this is sequential search. Okay, now here some points regarding linear search is, we do not have any information given about the array. Second, the given array is unsorted, means we do not require the sorted array in case of linear search. As I have told you that in case of binary search we required a sorted array, but in the case of linear search we do not required sorted array. we have unsorted array, and we are just applying our search algorithm in this unsorted array, and we get found that particular element that we want to search. Okay, now next, the list of data item is smaller, means we cannot apply this linear search in the very large data items. Okay, if you have limited amount of data and from that data you want to search, then you can apply linear search. Okay, that's why we are saying that data item is smaller. Now basically linear search is less efficient when compared with the binary search and hash tables. We are having different type of search where as I have earlier told that this step, or you can say this point already clear to you, that we are searching in a smaller type of data. That's why it is less efficient. If you are having more data, or the data is very in large amount, then you cannot apply this linear search over there. Okay, now you can see one example here. We are having one example. Suppose we want to find 20, and we are having given a list of elements of array. Okay, so you want to find the element 20. Now what we have to do, as I have already discussed, that each element we have to compare with the element of the array. Now we want to find the element 20. Now what we have to do, we just first compare 20 with this 10. Is this equals to? No. Then we are traversing to the next position. Again we are here comparing 20 is less equals to 50. No. Then we have to move next position. Now here again 20 equals to 30. Again search is unsuccessful. That means here also unsuccessful. Okay, as I in first slide I have already told, if we are having two cases, one is search is successful and the second is search is unsuccessful. Okay, so this is the second case. Here our search is unsuccessful. Whenever the search is unsuccessful, we are just going to again forwarding till the end of the array. Okay, we have to find any particular element, so up to there we have to searching that particular element. But suppose we just found the element at, suppose we are comparing here again, then we are comparing at this position, we are comparing and at the position 6 we found, that means 20 equals to 20 equals to 20 we found. Now search is successful. We can say search is successful because the element at the position of it's the position 6, we are having 20 and the element that we want to find is 20. Now you can say the search is successful at the position 6. We found the element at position 6. So that time you can say this is search is successful. But suppose if we are having suppose I am having 3 more elements. Here also I am having 30, 20, 10. You can easily see, you can easily check that we are having one more 20, one more same element that we want to found is at position 20. So in linear search, what we have to do, we do not move forward. Why we do not move forward? Because we found the element at position 6, then there is no need to searching in the rest of the element. Either we are having that element or one more duplicacy or not. That is not required to find out. We are just having the question that we want to find element 20. No matter where the element you found, at the first position, at the last position, the first time or the first time you get the searching successful, that time you say the element is at position 6. You no need to search again and again. Okay, so the searching complexity here is decreasing If you going to start searching from here, and if you get the position, if you get the element at this position and still you are going to searching again and again, then this is not a good for this algorithm, or you are using that waste of the time, waste of the you are taking so much complexity in your program on your algorithm, that increase the complexity of that algorithm. So there is no need to search rest of the element. Now this is two more example here. Like we are having a array, and in this array we are having the elements. You can see the elements. Okay, we are having these elements. Now we want to find a particular one element. That suppose we want to find x110, then what we have to do, we just traversing each element one by one, and at the position where our element and the element in the array is match, that time you can say search is successful, and output going is to be the index of that. Suppose this is the 0, 1, 2, 3, 4, 5, 6. So you can say element x is present at the index 6. Similarly, we are having these elements in an array, and we want to find out this x175. Then what we have to do, again we are just checking each element, or we are just comparing each element with the element that we want to find. So one by one in sequential searching we are going to search, we are going to traverse our array, but you can see here we do not get any you can or we can say we do not found the element 175 in this array, then we give the output -1. So I think you can say this is for search unsuccessful. You can say search is unsuccessful. So let's see the algorithm for this linear search. What we have to do, first we have to iterate the loop from 0 to n-1. By 0 to n-1, suppose this is the array element and this is indexing 0. Suppose 1, 2, 5, 6, 8, 3. These are the elements of the array. Now 1, 2, 3, 4, 5. Now searching is start from this position to until we get the element. Okay, so maybe the element is present at here, then we have to start loop from the position 0 to position n-1. Suppose n we are taking 6. So from where up to where we have to search the element? From 0 to 5, because as I think you all aware about the concept of indexing in arrays, that indexing is start from the 0 to n-1. Okay, so this is the first point. That means we have to iterate our loop from 0 to n-1, and then what we have to do, we have to compare the value of every index. Okay, that means suppose we want to find out the element I think this is 5. Then what we have to do, suppose we have to find the element 5 in this array. Then what we have to do, we have to just compare each element of the array with this element. Okay, so these are the given steps we are having to solving this problem. Solving the searching problem. Start from the element leftmost element of array. Like this is the leftmost, this is the rightmost. You can say this is the leftmost and this is the rightmost. So from here we have to start our searching, from here to move toward the rightmost. Okay, each element, and one by one compare with each element. Similar that I have already told you, we are just comparing each element. If the element x matches, then you can return the index. Suppose here our element is matched, then we return at position 2 or at index 2 our element is found. If the element does not match, then we return -1. So this is the simple logic, or simple algorithm of the searching. Now I am having the logic, like this is the iteration. Suppose from i0 to n n-1. Sorry, there is one correction. So our loop is starting from i0 to n-1. We are starting our loop, and here this is the comparison. Okay, this is, we can say, iteration Okay, 0 to n minus 1, that means from leftmost to rightmost, and this is the comparison. That means we are comparing. What we are comparing? The number, suppose number that you want to find, with the indexing of the, or you can say the elements of array, with the element of array. Okay, this is the element position of array. If this is true, that means if the, as you know that what is the concept of if and else, what are these are the conditional statement, and what are happening here. If the condition is true, then only we enter into the loop. If the condition is false, then we are just iterating the outer loop. Then we are just initialize the value of t. We are taking at a starting 0, and after the value become true, we put 1 here. That means the value of t become 1. That means you can say our search is found. This indicates search successful. And why we are using this break here, and what is the purpose of this break? As I think you all aware about the concept of break. Break is basically used to exit from the entire loop. That means we are having two iterations. We are having if loop and we are having the for loop. In if you want, in with the help of this break, what we have, what is happening here, we just come out from this for loop here. Okay, no further searching. That means we are, if we found our element at the position of 3, then we are not going to further move. Or suppose we are having the elements 6 element in our array, and we found our element at the position of 3, then we are not going to search further in our elements. Okay, further in our array we are not further moving or further searching. So that's why we are using break. At first, in any position we got the element, then we just print the output. We just said the search is successful. Now we are having one example related to one program related to this searching. So these are the header files. As you know, std.h for the input output, formatted input output functions, we are using stdio. Conio.h is for clearing screen. These are the header files for these functions, which for the predefined function we are going to use in this program. Then our program is starting. We are declaring our array of 50 size. Okay, then here we are taking some element number variables. So these are the, then we are entering size of array, and then here we are our loop, we are entering the elements. These are the simple program that you have already discussed, or I think you are all aware about in array. So that time you are using this code, but our main logic is here. Our searching logic is here. As you see here, we have searching from 0 to n minus, here is we are using n minus 1. Our searching is start from n minus 1. Then we are, suppose m we want to search, here we entering the m, then we have to compare this m with the I. Then if the search is successful, then t become 1. So okay, at the starting we are taking t equals to 0. If the search is becoming successful, then t assigned with 1. And after that, what is this p and what is I? I is basically used for printing the location. So from when the break we are using, it come out from the loop, and we are here. If t equals to 1, yes, we are assigning 1 equals to 1, because here we already put the assigning the value 1. Then our element is found with the position p, the position where we found the element. So this is all about linear search, and you can see the output of the linear search. What is the output? Basically, in first what we are entering the size 6, then these are the element of 6. We want to find the element 15, so element found at the position 4. So this is the output of the linear search program. Now this is the complexity, means if you are talking about the best case, at first if we get the element at position first, you can the search is successful. if the or you can say the best case, you can say search is O1. Okay, that means at very first position, means at the starting. Suppose we are getting is this location, then you can say this is the best case. And what is the worst case? If you do not found any element, that element in that array, if you are traversing one by one whole the array, but still you are not finding that particular element, then you can say this is the worst case. So in this case, the complexity you can say O(n). So I hope these are the cases of best case. And so these are the best case and worst case of linear search. So that's all for this lecture. We will continue this this searching algorithm in next lecture. We are having binary search, so we will discuss the binary search in the next lecture. So in linear search we are having these. So that's all for this lecture. We will continue this lecture with the binary search. So for till that, thank you. Jai Hind.